Okay, so continuing on, this is almost our last type of partial fraction. We're going to go ahead and factor the denominator, so that gives me x squared plus 3. So I've got two factors, so I'm going to have two fractions that came together to give me this. First one's fine, x. It's a linear factor, so I'm going to put a linear or a constant up on top. We always want the degree to be one less. So my second factor, x squared plus 3, has a degree of 2. There's a possibility that there was an x up here. So we have to take that into account. So we're going to put bx, and we cannot just leave it bx because there is also the possibility that there's just a constant. So it could have a combination of one or the other or both. It could have none. Both of these could be 0, but it has to have the possibility of having an x in both the top and a constant. So anytime you have a quadratic factor, you're going to put an x up top. If it was a cubic factor, you'd put an x squared, x, and constant up top. We probably won't work with those, but it just continues on in that pattern. From here, the process is the exact same. We multiply through by my denominator, x squared plus 3. That gives me x minus 3 on the left side. The x's cancel, so we have a and x squared plus 3 left over. Then we have my bx plus c. You have to be careful. That's one value, so we keep it in parentheses, times x. So this one's not terrible at this step. That gives me ax squared plus 3a plus bx squared plus cx. Then we can go through, pull my common term, my like terms. So a plus b has to equal 0. There's no x squareds over here. Then if we keep going, we don't have, oh, we do, right here. So c has to equal 1. Then we have 3a, that's my only constant, that has to equal negative 3. Now this one would be one where you could definitely do this by hand, but we'll keep trying on the calculator. So this is still a 3 by 4. We got 1, 1, 0, 0, 0, 0, 1, 1, 3, 0, 0, negative 3. Solve it, same way we have been. That tells me that a is negative 1. So I'm going to take him out, put it at negative 1. Tells me b is 1. So I have 1x. And c is 1. So in this problem, you don't need the 1. You could have just put x, but we could put it in there just to be safe. You do need the c being 1. In this problem, you can see that we did need both of those x and constants up top. So the quadratics, like I said, no harder. You just have to remember that what goes up top is going to include an x and a constant.